Very warm welcome to our first Exploring Resilience webinar. The idea behind this is to actually, to first of all connect the different researchers in both the Resonate and the ONEforest project to receive feedback for PhD projects or papers that you're planning, to find out what the other researchers are doing, and to first of all, of course, also to connect you within the project, but then even beyond that, because we know that in research, actually, a lot is about networking, a lot is about building your community, engaging with your peers, and a lot is also about communication. I'm not just saying that because I'm working in communications, but it's also about how you bring your research to your peers and how you engage on your research questions. So very warm welcome from my side. My name is Gesche Schifferdecker. I'm leading the work package in comms in the Resonate project, and I am also leading the communications team of European Forest Institute Bonn. And I would like my fellow moderator Raquel to also introduce herself, and then we will start with the first presentation.
Good morning, everyone. Thank you very much again for being here with us and join this first webinar together with Resonate and ONEforest. I'm part of the representatives of ONEforest project. Both of them are H2020 projects. So thank you very much. And yes, I hope we will continue this webinar soon, and you could get some inspirations, networking, and maybe in the future, in the near future, work together. So thank you very much.
And so the idea how we were planning to do this is to have 2 presentations in each webinar, and to have these presentation in a little bit of a unusual way for researchers, to have maybe a story that you tell around your research, to maybe have the content prepared in a way that you usually don't use when you go to a scientific conference, but when you reach out to other audiences. And this is also, we also see this as a chance for the presenters to learn or to try it out for first or second, or maybe then even in the future more times, to present in an engaging format. It is the first time now, so thank you very much, Marju and Laura, for being our guinea pigs. It is thank you for taking the challenge. We are really excited to listen to you, and then after, I would suggest that after Marju's presentation, she will be the first one. We will have the possibility to ask questions, to engage in a discussion also amongst each other. And if you are not like ready for that yet, we would just continue with Laura's presentation and then have a discussion afterwards. So there's some flexibility. We're also trying this out now for the first time. So let's see where it takes us. Okay, enough of the talking. We have almost 15 people in the call now. That's awesome. And we will start now with the first presentation of Marju Kaivapalu. And please, Marju, introduce yourself and then start with the presentation.
Okay. Hi to everybody. I'm Marju Kaivapalu. I come from Estonia at the University of Life Science, and I will try to So I'm the first, so I say it was quite difficult to do this kind of format. So let's see how will I do. And I will share my screen. So, can you see my presentation? Okay.
Yes, we can.
So let's start. So I'm gonna tell you about the uptake of heavy metals in hybrid aspen plantations. As I said, I'm Marju, and I come from the University of Life Science. I'm a first-year PhD student, and I represent my research team with this. This is part of my first article, and this is not yet been published, but I think we will try to publish the end of the year. So in my research, I look plantations in former agricultural lands and in Aidu oil shale quarry, and this picture is from Aidu. A little bit about the background, the overview of oil shale deposits. In this map, you can see that oil shale is found all over the world. It is in 600 deposits in more than 30 countries. So there is lots of areas to be restored. So it is important to investigate it so how we can restore it. And the production of oil shale, I have to say that Estonia is the world's biggest producer for energy from oil shale. And in this picture, you can see the production of oil shale in the years 1890 to 2010. And after 2000, the production of the mining has been decreasing, and but actually the situation in the world is in Estonia is really poor, and in this year and the next year we're gonna mine more oil shale than we expected. So this is quite a lot of change for us. And elevated heavy metal topsoil concentrations are associated with industrial areas, so the pollutions from air pollution from industries like cement factories, maybe fertilizers, and the other big industries, and also in mining areas. And so these areas need to be restored. And so one way to restore the areas is to use plants. So the use of plants in polluted sites and media to reduce toxicants is relatively recent technology, and it is considered cost-effective. It's novel, eco-friendly, and solar-driven technology, and also has a very strong public approval. So that's why we decided to investigate this. And the previous studies show that hybrid aspen is the suitable plant for these polluted sites. So our research aim is to find out the dynamics and interaction of heavy metals. And also we look important nutrients, so how they affect tree growth and how they absorb from soil to plant. And so once again, why we choose the hybrid aspen? Because this is fast growing. This has a higher production potential. And also in literature, we found that these are optimal plants for absorption, accommodation, storage, and degradation of environmental pollutants such as heavy metals. And about heavy metals, we can divide heavy metals in different ways, but the one way is to look them like this, that they are some of them are important for a tree to grow. So like copper, iron, magnesium, nickel, and zinc. But some are non-essential, so plants don't need these elements, but they are in the soil, so they absorb them also. So these are like lead and mercury. And also in some levels they can be harmful. The same heavy metals that are important for trees to grow can be harmful in larger amount, like mangan and zinc. And in our research, we analyzed 11 heavy metals. These are arsen, lead, cadmium, chrome, nickel, zinc, iron, molybdenum, copper, cuprum, and mangan. And has said that heavy metal can cause significant alteration in tree physiology and forest ecosystem functioning. So we have to pay particularly attention to heavy metals and how they absorb from soil to wood. And now about our research and about our plantation. So here you can see the location of Estonia, but you already know all about that. And here is this in this picture, you can see the Estonian oilseed deposits. This is red area, and our tree plantations are in this red area. And this is one more picture from Aidu. As you can see, this is all green and nice, so it's been forested years ago. And briefly about the methodology. So we did field work in Aidu, like I said. We have there two plantations. One is with restored soil, and the other one is just platted on the quarry. And former agricultural lands are in West-Viru County. It's near this red area from this map. And also one plantation in Tartu. This is where our university is located. And this is our control area. So we took samples from soil, from upper layer. We analyzed the pH and heavy metals, and also important nutrients. So we took drill cores from the wood, and we analyzed two different decades. So we took the drill cores, we counted the years, and so we cut the cores into two pieces, and we analyzed separately. And we took samples from bark, And we also measured tree growth height and diameter. And here is some pictures from our research area. So you can see this is the plantation in Aidu, oil shale quarry, where we just planted the trees in quarry with no soil. The trees are about, not about, but they are 20 years old right now. Here you can see also from Aidu picture, and this is a quarry with restoiled soil. So we just before planting, we deployed it about 20 centimeters of soil, and then we planted the seeds. So as you can compare these two pictures, you can see that in quarry they are really tiny, and but with restored soil you can see that the trees are growing much faster and thicker. Here is one picture from agricultural land. This is we indicate that this is polluted area. It's near Kunda cement factory, and this is one picture from Tartu. This is our control area. And the first results from our analysis, here we can compare these three areas, three plantations, quarry with restoiled soil, and former agricultural land. This is this polluted site. We don't have yet the results from this control area. We don't have this from laboratory yet. But let's see, compare these three. Like in this picture, you can see that they are all the pH is above 7. So we can say that heavy metals are hard to absorb in all three plantations. So potassium level is high in former agricultural land, and we can indicate that this is because of the using the fertilizers in former agricultural lands. And it's really interesting to see that potassium level in quarry is really low. And also we can compare carbon to nitrogen rate. And here you can see that the rate in quarry is really high, so it's above 65. So this means that the mineralization doesn't occur, and the nutrients are hard to absorb. But in quarry and in quarry with restoiled oil and in former agricultural land, the mineralization occurs, and the nutrients can absorb. And about results from heavy metals, here is divided important for tree to grow. Here you can see nickel, copper, zinc, iron, and mangan. And here you can see in all these picture that this bar is much higher. This is this former agricultural land. So we can conclude that in this former agricultural land, the concentrations are higher, and this site is polluted with heavy metals. If you look forward, the non-essential heavy metal for trees, we can see lead, copper, chrome, arsenic, molybdenum, and cadmium. And in this picture, we can also say that if we look this bar, that former agricultural land are polluted with heavy metals. Like I said, we analyzed also bark and wood. So the yellow bars are bark, the blue ones are stand age 1 to 10, and orange is 11 to 20. And I have to say that some heavy metals were below the limit of termination, so there was no results. So we don't have the picture from them. So the content of metal were really low in other words. So here you can see mangan, nickel, iron, and zinc. And here you can see a lot of yellow. So we can say that in bark, the heavy metal content is higher than in wood. And if we compare these 4 areas to each other, we can say that heavy metal content in quarry is usually higher, like you can see in here and in here and here also. It's almost like that, but like in zinc it is a little bit different. So that in quarry the heavy metal amount in wood is higher than in quarry with raised soil island in former agricultural lands. And if we look forward, non-essential elements, chrome, cadmium, and copper, here we can see that it's high variability, like really different results. In this we can see a lot of blue, in this we can see a lot of yellow. So, but we can conclude that in quarry the heavy metal content is mostly higher, like you can see here. And these blue bars, like I said, stand age 1 to 10 contain more heavy metals than stand age 11 to 20. So we thought about why is it so that maybe the trees are growing faster and they absorb these elements much faster, and also because the water efficiency use is faster in younger age than in age 11 to 20. And the conclusions so far. Like I said, in Northwest Estonia, various elements are higher. So it indicates that pollution in Kunda, because there is the production of cement have been taking place since 1971. And the carbon to nitrogen rate is 65. So this indicates that the stands are very poor and nitrogen uptake is limited, so that it's really hard to trees to grow. The concentration of heavy metals in wood and bark are mostly higher in the quarry. And the content of heavy metals in stand age in 1 to 10 years is usually higher than in the stand age 11 to 20. So as we can conclude that hybrid aspen are suitable for phytoremediation. This is for use for this to reduce toxicants in soil, and it's suitable in post-industrial landscapes, like I said, in Aidu and in this former agricultural land near Kunda. So that's it for me. Thank you for listening. And there you can see all our supporters. So I thank all the funders also.
Thank you very much, Marju. You can see all the clapping hands. If we were in the same room, people would do it physically. Yeah, first of all, thank you for being so brave to do this first. If you like, I would start with a little feedback, and then others can ask questions. I would like to give you some feedback to the narrative, if you like.
Yeah.
Okay. Well, first of all, I think it's a topic that I mean, you've used a lot of scientific material, which I think is really interesting for this group. Although some might be very, very specific, but probably still interesting, for which would not have been interesting for like when you present this to a broader audience. However, the topic, I think, is and this is maybe the next time when you start a presentation, the angle that you could take is that there's a lot of potential actually, because we have all these areas that are polluted by toxicants all over Europe. And there's a huge potential to restore the soil there, and to make us all live healthier life by planting specific tree species there. And you've already identified a tree species that is at least proper for this area, because it grows fast, and also because it can perfectly absorb these environmental pollutions. So it's a kind of the superhero tree that you've identified. I'm just, I'm using a specific terminology that people can relate to, and I was also very surprised by the combination of trees and heavy metals, because I have not thought about this before. And I think this is also something that where you could take this angle, that for people to get engaged, that because people are most people think about the music first, I think, but like when you then think secondly, like about heavy metals that we all know, like arsen, for instance, or nickel, think, just taking some examples, that people would not relate it to trees at all. So it's quite a surprising thing to bring together. But then, of course, when you talk about the restoration aspect and how trees can be used, then this is a really nice story that you can build around this, to make it engaging. What you're doing there is a very interesting example that can also maybe lead to soil restoration all over Europe eventually. So it can be inspiring for others. So I think there's a lot of potential actually in the narrative, and I very much like that you use so many images and less text. So that's really good. And you're obviously a good photographer. So that's something that is really nice. And I mean, some of the information was too specific for me, but I'm also not a researcher, but a science communicator. But there was a lot of, I think, very inspiring news in this presentation. And now I would like the others to give some feedback or comments or questions to this research. Okay, only one question that I had is, how did you actually find this project? I mean, what was the kind of initial decision? Was it a government decision in Estonia to restore these sites, or to like who has identified that this former agricultural land is so polluted, and who came up with the idea to actually use plants to reduce this toxicants. So that maybe just as a first question, then the others can take over.
Okay, yes. In Estonia, if you contaminate some area, so you have to restore it, and this is by the law. And so if you mine like this big mining areas, you have to restore it, and then you do this kind of restoration project, and you can decide what you do with it. Maybe you do a forest, but you can also do like some lake or something to this area. But this particular project was because we don't have this kind of information about. We have pure information for heavy metals pollutions. So that's why they decided to do this project to get more knowledge for this. Yeah.
Thanks. That's very interesting, and also the fact that it's enforced by law is interesting. And I wonder how this is done in other European countries. But I will further explore that because now you got me interested. Are there any other questions or comments from Laura, please?
Hi, thanks, Marju. Very interesting presentation. And also, I feel it was really difficult to prepare for today. So let's see how it goes for me. I was interested because you said, like, now you study how the trees accumulate the heavy metals, but what is the plan to do with the trees afterwards? Like, will they be cut and burned, or what? How are they like the further processed, or will they just be let to grow there for as long as they grow?
Actually, some of them, this fourth area in Tartu has already been cut mostly, but only for trees for me are standing to investigate. So yeah, this hybrid aspen mostly is used for biomass, so for energy, but also for this. Also, they are like this small. How do you say it? For small houses to burn, like not you, like
like firewood or
yeah, firewood. Yeah.
Okay.
They are all. I think they are all cut. This in few years they are all being cut. So.
Okay. Thank you.
Thank you.
Thanks, Laura. And Annihin is the next one.
Yeah, actually, my question was just answered.
Okay.
So, but I wanted to say that this is a great presentation, and I really like the topic. And I think it's also very interesting for us in Resonate because we like to know what would potentially minimize the climate resilience of forests. And I guess heavy metals are definitely one of those factors that are minimizing this. And we need to find out how to deal with such factors. So thank you for the presentation.
Thank you. Thank you.
Thank you. Raquel, you're next.
Okay. Hello. Congratulations for your presentation. It was quite a shock to see how these trees can absorb all these pollution. So thank you very much for even some light. And I would like just to know, since we are working in the same project in ONEforest, which is the link from your research within with ONEforest project?
Mm-hmm. Actually, yeah, that's really a tough question for me because I don't yet know much about this ONEforest project, but I think this fast-growing tree species are also one part of this, like this project. and we can see like all the plantations in Estonia, and in our further work we're gonna analyze also silver birch and more sites in Estonia all over. We have like 50 sites more that we analyze, so we can get really good knowledge for all our region. So
okay,
I don't know
great.
if okay.
It's okay. I mean, I know that you are doing a lot of research right now, so in different areas, so you will get some information, valuable information for the project for sure. Thank you.
Maybe there's Sebastian, for instance, from the ONEforest project, who could shed some light on Raquel's question. Sebastian, are you there?
Yes, I'm there. Sorry, but I am, yeah. Currently, I had some technical issues, so I didn't get half of the presentation and the question of Raquel. So, what was the question, Raquel? Sorry.
Sorry, I was muted. My question was, what is the link between the presentation that we have seen today with ONEforest project?
Usually I would say that we are aiming for a criteria decision support system. So we are trying to find, or we are trying to underlay, I put my camera as well. We're trying to underlay maybe needs and for decision makers, for foresters, for politicians, and there are certain needs on a forest management side, also on a societal side, and I would say there are different aspects that could be the goal of a forest. So at one point you can produce wood, and on one side you can produce or you can plant a forest to actually reduce the hazardous elements within the soil, and therefore I guess this would be one part on how to choose what kind of role the forest actually plays in a region. And if it actually has a vital role in reducing hazardous elements in the soil for a better living for the rest, and there is a societal benefit that could be chosen as one of the, let's say, outcomes, and in the end you get a management where you get different approaches how you can actually manage your forests in order to reach those different goals. I hope this clarifies a little bit more. So it's to come back, I would say it's a facet of the few of the many different aspects we're looking into. So hazardous forests, touristic forests, ecosystem services, and I would put this one very much into ecosystem services of the forest, but not on the usual side, let's say, trying to actually protect from avalanches or anything, or water resources, but also on a side that we might not have looked into very much so far.
Yeah, that's I think that totally makes sense to me, and I think it's also it's an aspect that has not been looked into so much yet, but I think it's a very relevant aspect also for society and also for policymakers, and maybe also to inspire others with what is done in Estonia. So thank you very much. There's still one, Marcus indicated that he had some comments. I think it would be really nice if you would actually share them, not just in the chat, but also in the video, and then we will have Laura's presentation after Marcus' input.
I hope you can hear me, because I have a little bit difficult setup here. Do you hear me?
Yeah. Yes, perfectly.
Just a short anecdote. I was studying with one of my first assistant jobs as a student. I was actually studying heavy metal pollution in trees, where we were cutting trees along motorways to study if the lead was actually taken up by the trees or not. And we also had some studies of other vegetation. But anyway, I was thinking that in the narrative you could maybe have added, or maybe I missed it, I'm sorry if I missed it, but there is of course plants who are not surviving in such polluted soils. So maybe adding a picture of a plant that is more sensitive than the aspen could have been like showing that not all plants can actually survive if they are actually in such an environment. And I think you want to give the impression that this aspen, of course, is a good way of restoring the site potential there. So having this contrast that some species would not survive, but actually you have a species that is actually able to thrive in such conditions would be helpful. And then I have another question, but it's more for I would have been interested in like how this agricultural site was actually polluted. I mean, just mentioning where that pollution comes from would be also maybe helpful, because I didn't get that. Like, how could it be that this former agricultural site is actually the most polluted of those? But then, yeah, a comment on the other questions. You take up some of the pollution in the wood. So if then the wood is burned, for example, there could be a pollution released from burning. So that's a concern. You want to know where is this heavy metal. So if you want to then burn the wood, is then all the heavy metal spread into the landscape? So that's something that you should also a little bit mention when you're thinking about the future use. Yeah, and then there's a more technical question, but I think this is going to really too far. We put that into the chat then. But thank you very much for the nice presentation.
Thank you. Yeah, about this, like I said, it's polluted this agricultural land because it's near the Kunda cement factory. So
Okay.
that's air pollution. So that's, this is about 200 and so years more. The cement factory have been there, so that's why this is more polluted.
Okay, and is that a wide-scale pollution, or is it just like really narrowed, like very close to the?
It's quite a large area in this Kunda. So I don't have these all results about this soil, but there in 10 years ago there was one research that took soil samples from other places as well. So it's quite in Estonia. It's quite a known problem that this Kunda.
Yeah, well, I didn't know it, so but thank you for clarification.
Yeah, I can see there's still Sandra. We are still okay in time, so if you keep it short, then please, would be great to also hear your feedback.
Oh, I just have another question. I have a question regarding that, because you just, I think it was a great presentation, and I was really, overwhelmed. So about the figures and the concentration of the heavy metal in the trees and the different part of the trees. But what I would also be interested in is what's about the soil? Did you also measure the load of the heavy metals in the soil? Is there some decrease of heavy metal, or is it not worthwhile to measure it because there are still additional loads which are coming to the landscape? Could you say something about that?
I don't. What do you mean about loads coming? You mean more pollution?
Yeah, more pollution.
In Kunda, actually, no. I think there is a lot of this been done to reduce this pollution.
Mm-hmm.
In Aidu, I think it's the same. There is no pollutions coming, but actually these analyses are very expensive, so laboratory. So that's why also there's little information about. So we can't compare this like 10 years ago, 5 years ago. So we don't have this kind of results. We can,
but now you only measure the concentration in the trees. Do you also measure the concentration in the soil as well, or is this due to that restriction in costs and so on?
No, we analyzed in soil and also in wood, so we can see how they uptake these heavy metals. Yeah.
Okay. So probably I missed it.
Okay, well then, thank you very much, Marju, again, for this inspiring presentation, and I hope the feedback was also useful for you. We will have our next presentation now, and it will be by Laura Nikinmaa from European Forest Institute. Yes, so we can see the camera, perfect. So yeah, please briefly introduce yourself, and then we are excited to hear your presentation.
Okay, thanks, Kirsche. So yeah, I'm Laura Nikinmaa. I'm currently located in Joensuu in Finland, but I started my career in EFI. So I'm a junior researcher in EFI. So I started it in Bonn with Kirsche and Markus. And I'm a bit in a different position as Marju because I'm close to finishing my PhD, and I have done that in KU Leuven in Belgium. So in this presentation or TED Talk, I will briefly run you through the 4 years, like condensed in 15 minutes. So let's see how it goes. And also, I'm a big fan of TED Talks. So this is my take on how I would give a TED Talk if I would give a TED Talk. So let's see how it goes. Okay, first let's see. Now you see. Which screen do you actually see now?
We see the presentation, and we don't see notes, at least not now. Yeah, so it should be perfect, this presentation mode.
Perfect. Then let's get started. So do you guys sometimes imagine how forests in Europe would have looked like, sometime previously? Because I do quite often, in fact. I always wonder how the Caledonian forest from the Tales of King Arthur would have looked like, or how the ancient Mediterranean forest was before the Roman Empire, or even if how the Finnish forest would have looked like before the clear-cut systems were introduced in the 1950s. And as I do wonder these, how the forest would have looked like before, I also wonder that how the forest will look like in the future. And I'm getting more and more worried because I'm a bit afraid that we might not have the type of forests in the future as we do today. And can the kids then even imagine what forests look like? So when I started my PhD in June 2018, I was still in Germany, and Germany was hot, like very much like today, I assume. I remember sweating while sitting down in the office, having difficulty sleeping because it was so hot, and also the endless consumption of ice cream because I needed to have some way to cool myself down. But I also remember that there was a lot of worrying stuff on the news, how we were constantly breaking some, heat records, how there were fires in not only in Mediterranean, but also in Germany, where we were not used to having fires before. And also the bark beetle outbreaks that then came as a result of the unprecedented drought that we saw. And it was like with this new, it was becoming quite clear that we need to somehow do something to change change the way we behave and change the way we manage forests to somehow be able to adapt to the current changes in climate, yet alone to the future changes in climate. So we needed to find ways, or we need to find ways, how to make forests more resilient. And we needed to do it now. So I started to tackle this problem with great enthusiasm because I was on my way to save the world, as all of us are in the beginning of the PhD. But I very quickly ran into some problems. First one being that to increase resilience, we needed to know what it is. And there were very many confusing and differentiating meanings of resilient in the literature. And the second one was that because of the so many different meanings, there was actually no commonly agreed metrics to measure resilience. So I wondered, how could forest management be changed if we did not know exactly what we needed to improve? So what would we need to, change in forest management to improve this thing? Or if we did know what we were supposed to improve, we had no idea how to measure and therefore monitor it. And as I'm a person who is slightly obsessed with organization and putting things in the boxes, this type of conceptual unclarity was simply a horror for me. And I was also contemplating on completely changing disciplines to mathematics or something for the clear definitions. But I'm also quite stubborn, so I decided not to give up and instead start to create some sort of order into this chaos. And to start solving these two problems, I identified 3 questions to be answered. First one being, how is resilience used in the current scientific literature? Second one being, how can forest resilience to disturbances be enhanced? And third one, how does forest management need to be improved to address the climate change-induced challenges? In the forest, kind of literature close to forest, there are 3 commonly used definitions of resilience. The first one being engineering resilience, which refers to the time that it takes for a forest to recover after disturbance. The second one is the ecological resilience, which is the capacity to absorb disturbance and adapt. And the third one is the socioecological resilience, which refers to the capacity of a social ecological system to absorb disturbance and adapt and transform into a more resilient system. To answer my first research question, I investigated how these 3 resilience concepts were used in the literature, how they were measured, and also what were the similarities and differences between them, as well as how their use had evolved in the last 20 years or so. And I did this by conducting a systematic literature review that started with quite many abstracts. I think there were a couple thousands of abstracts. I also read a few hundred papers. And then the final set that was involved in the interview was 255 papers. Out of these 255 papers, I analyzed what type of systems they were studying, what type of disturbance these articles were addressing, as well as how were they measuring resilience and what type of indicators did they use. And while I was doing this analysis, I could see that there was a pattern emerging, that actually these 3 resilience concepts were not so much contradictory, but rather they form this type of hierarchical structure, as you can see in the picture, where the engineering resilience is kind of a part of ecological resilience, because to absorb disturbance, you need to recover from it. And ecological resilience was part of social ecological resilience, because forest is a part of the bigger, wider socio-ecological system that we all live in. And it depended more on the type of question you had and the type of system you were analyzing which resilience concept to choose, rather than, okay, I need to, agonize over which is the correct one. So it's more this resilience of what to what, as was already explained by Carpenter and all in 2001. And I was quite ecstatic to kind of find this structure, because me wanting to put things into boxes is, having structure is a good thing. But there was still the problem that how to measure resilience. I hadn't done anything to solve that yet. The literature review had shown that there was quite many different ways to measure resilience, especially engineering resilience. But I wondered, in this time when forests are facing climate change, biodiversity loss, and there is market volatility, just to name a few, the time that it takes for a system to recover from a disturbance just didn't seem like it would be enough anymore. So I started to look into how this socioecological resilience, which kind of encompasses both the ecological system as well as the society around it, how this concept could be measured and assessed. So I hope you enjoy the picture on the beach. But anyone who knows anything about forest management is aware that there can be quite many different trade-offs between different ecosystem services and between the different uses of forest. It's quite obvious that one cannot maximize both the production of timber to get the most timber out of the forest, as well as maximizing the carbon sequestration or the carbon storage of the forest. It's not possible to do them at the same time. So these trade-offs need to be somehow balanced. Similarly, in socioecological resilience, there are these type of trade-offs. For example, if one wants to increase social resilience of the forest owner by carefully using all parts of the wood to bring in more revenue with timber products, with biofuels. But at the same time, you'd actually take all the nutrients out of the forest, because you take everything of the wood out of the forest. So you actually decrease ecological resilience. So you increase social resilience, but decrease ecological resilience. And this doesn't work in the long run. So we wanted to create this sort of framework where this problem of trade-offs and how to balance them was explicitly addressed. And by we, I mean several colleagues who are also in Resonate. We work together to create this type of framework. So we created this framework with several principles, criteria, and indicators, where the need to balance was addressed in the context of forest management. And we created a procedure how this framework could work, or would be applied. And we also hypothesized how the results of the framework would change with different forest management goals. The key message we found was that forest management resulting in the highest socioecological resilience depends actually quite heavily on the forest management goal, as achievement of the goal could be considered as an important part of resilience. Of course, there might be some goals that are not achievable at all. For example, trying to grow a very productive forest in these heavily contaminated sites, as we just saw. So there is some caveats to this, but I would imagine that quite often forest managers and forest owners have at least an idea what would be realistic in their existing conditions. So the main point is that the management steps to increase resilience to, for example, an owner that values timber production above all, or an owner that values recreation above all. So these steps are not the same. So you are saying that resilience is subjective and there is no universal truth to it. You might be wondering right now. And I would say that to a certain extent, yes, because it depends so much on the goal. But at the same time, forests are still forests, and there are some universal truths or general kind of rules of thumb that do apply. For example, the diversity of species and structures enables several different possible responses to different disturbances. While at the same time, if you have different revenue flows from not only timber, but perhaps also from recreation or other forest-based products, you are not necessarily faced with such a big calamity or financial loss in case there is a big disturbance. So the question is more about what are the optimal values for different indicators measuring resilience to achieve the highest possible level of socioecological resilience for a certain management goal. So now I had a framework. I kind of had an idea how to put it into practice in the forest management, but I still hadn't really measured anything because the indicators in that framework were kind of theoretical still. So we hadn't tested them in the field. And it was clear that to assess the socioecological resilience, one actually needs to measure many different type of indicators. And for that, I didn't simply have the time to do in my PhD or resources at that. And at the same time, during these 4 years, we have seen that the hot and dry years keep following one another. And more forests were dying because of the drought or kind of other disturbances, but very often drought being the first factor to weaken the trees. So I decided that, okay, this is a serious time, so we need to be a bit more focused. And I decided to study how trees are influenced by drought in these repeating hot years. And I did this by analyzing how trees respond to repeating dry periods. And this analysis was done from the dendrometer measurement data. And in the picture, you can see what a dendrometer is. It's an equipment that measures the tree diameter change in short intervals. And they are relatively cheap and easy to use tools, which would make them kind of ideal to be used in monitoring of resilience. And from the dendrometer data, we can extract the measure of tree water deficit, which is basically kind of the measure of tree stem water storage, or it reflects that. So the higher tree water deficit you have, the less water you have in the tree stem, indicating that the higher stress the tree is experiencing. So it's therefore quite good indicator to follow or to look at tree stress. And I was very lucky to be able to use an extensive database on dendrometer measurements from all across Europe. And together with some colleagues, we looked at how long the tree water deficit periods were and how they were related to weather and, for example, the wood anatomy type of a tree. So, for example, coniferous wood type or diffuse porous wood type or ring porous wood type. And we found out that the length of these tree water deficit periods clearly increased with the number of their occurrence for both coniferous and ring porous trees. So it meant that with more periods, the length increased and the trees were not able to fulfill their stem water storages in between those times, which meant that they were losing their resilience to some extent. And so this was exciting because it could be it could tell then that, okay, this is a way that we can actually monitor in the long term tree stress. With the current analysis of the dendrometer data, it's a bit too heavy in the processing side, so it's not very useful yet to be applied in kind of operational forest management. But perhaps with more research, it can become really a quite nice tool, kind of like a pulse meter for the forest. Okay, I think I'm running a bit over time. Oops, sorry. But I'm almost there. So now I had a framework, and I had experienced or explored at least one way to measure resilience. But it was still kind of clear that there were some issues in putting the science to practice. I was quite positive from all the science I had read to get to this point that there actually is a lot of knowledge already on how forests can be managed to make them more resilient, but somehow it's not directly applied in practice yet. So there is this gap in putting science to practice. So to answer this question on how much of the research was actually going into forest management, I explored what are the forest management measures to increase resilience to disturbances studied by researchers, and also what are the measures to increase resilience to disturbances suggested by the forest experts, whom some of my colleagues had interviewed before. And to understand why the research is not necessarily going into forest management practices, I also interviewed some people who are responsible for developing forest management guidelines in different European countries. And what surprised me as the result of these literature reviews and these interviews was that there is quite clear difference on one hand, what are the forest management measures studied by the researchers, and on the other hand, what are the forest management measures suggested by the forest experts. So there was quite clear divide, and it also indicated that perhaps some of the forest management measures suggested by the forest experts don't necessarily have a very high evidence base behind them. So seeing this, I was also curious to see, okay, so it's obvious that the information from science is not going into practice. And I was curious to see what could be the possible barriers that are hindering this transfer of knowledge. And this I did by interviewing the people developing forest management guidelines. And quite several different barriers were identified. For example, the lack of resources, the lack of money. But one I think was particularly interesting for researchers was the lack of useful and applicable knowledge. So actually, a lot of the forest management experts are bombarded with information, so they are really overwhelmed. But they don't see how this and that scientific research results is necessarily related to their own condition, and where how could they apply it. So this was indeed quite a big of a problem. They would need much more local and concrete approaches to change forest management. Okay, now that my PhD is coming to an end, how would I summarize my PhD research? Can resilience to forest disturbances be influenced by forest management? And to answer these questions, absolutely yes. There is quite a lot of things that one can do to increase resilience. For example, just by increasing species diversity and connecting different forest landscape patches together to make sure that the recovery after a disturbance is facilitated. And this is just to name a few examples. And how do we need to improve forest management? Well, I think especially from the last chapter of my PhD, an important factor is to really engage in transdisciplinary research to really address and involve decision makers and forest managers from early on to really understand what are their knowledge needs and how can we as a research community to address them to really provide the best possible, the most informed forest management in the future. And I personally think that's the only way to make sure that we are somehow changing the status quo of forest management today. And coming back to my first question on if you ever imagine on how forests would have looked like, you might wonder if I really do think that forests will not exist in the future anymore. I do not. I do think that forests will exist. They are inherently quite resilient. And of course, a lot of different ecological calamities have happened before, and we still have forests. But I do think that they might be less diverse, a bit more boring, and also harder to find, and only to be accessed in very remote areas. So I think that's why we need to really pay a lot of attention on how we can currently improve our forest management so that the kids in the future don't need to, imagine so hard what the forest looked like today. Thank you.
Thank you very much, Laura. There was also a comment in the chat that Anniken feels like you managed to tell us all about your PhD in half an hour, which is quite an achievement. It didn't look, though, as if it was not a lot of work, so don't worry about that. It looked like it was a lot of work, but you managed to put it in a work. But you managed to put it in a really, really nice narrative. And yeah, maybe Raquel wants to start this time with giving feedback, and then we can have questions. And we still have 15 minutes to go.
Okay, I will be short. Congratulations for your talk. It was very inspiring, and I really appreciate your narrative. And because I'm not a scientific, I'm not a researcher, so for me it's quite good to not see a lot of figures, graphics, and so on. Use more audiovisual, so it was very challenging, I guess. But I really appreciate the way that you just tell your story. And yes, I learned a lot actually about resilience. So thank you very much for that. And I think it was a really great talk. So congratulations, and I will give you the floor for more questions.
Thank you. I'm glad that it turned out well.
Yes, really good.
Yeah, I always had tears in my eyes in the beginning when you're talking about the future and the kids and the forest, how it will look like. I was like,
that's the way that you can engage an audience. So really good work.
Exactly. So are there any further? I mean, there are lots of very nice reactions in the chat. That's for sure. But I wonder if there are any questions or comments from the side of the audience here. Cannot see any yet.
I guess it might be difficult because I really didn't present any details to be questioned.
Yeah, but there was also, I mean, there are like different approaches to this. Of course, Marju, who's in the beginning of her PhD, she was like really into the details, and you could kind of take the like, you could fly over your PhD project in a way, and look at it from a like broader perspective because you're almost done. But I could see the hand of no, now it was lowered again. Nicola, please.
Hi, hello. Can you hear me?
Yes, we
Yes.
can.
Perfect. Thanks. Sorry, I joined a bit later the presentation, but managed to follow. To follow your nice presentation and to understand all your information. It's really nice. I know that you made a paper, and I also, well, I know from the presentation, but I also noticed before your publication regarding the resilience review. And I was wondering if you maybe can have some words regarding the social economic aspect of the resilience. I don't know if it was included in the review. I think so, because there is social. Let me check again. Social ecological. Yeah, social ecological. But since for my project, I'm studying like the implication of enhancing the resilience of the value chain. So it's more connected with production of wood. I was wondering if you have like some, which is your idea connecting with the social part and the economic part. But it's also fine if you answer that you didn't explore this topic.
I mean, of course, in the review, I was so I don't have any background in economics or even wood processing industry that much. So it was slightly difficult for me also addressing the review. But I did come across in some papers, and it was quite interesting actually, because the studies I looked at that could be categorized under the socio-ecological resilience, there weren't that many in the forest sector, or they didn't come up in my review as such. So I think when I did this review, it was in, if I remember correctly, I ended kind of the inclusion of the papers in 2018. So it could be that since then there has been a lot of new studies on that. But at that time, there was very few studies that were looking at the kind of forest industry resilience. And there the only studies that came up usually emphasized on this diversity of different products, flexibility on somehow on the, how is it called, this, the processing, that you don't need to produce certain amount every single day, but there is some kind of flexibility in that you can somehow control in case there is, for example, a lot of wood coming in due to, I don't know, any forest disturbance, or then in some cases that the wood prices are very high, if you can then lower your production to kind of ride out the highest price, so then the resources are not so expensive. So I think there is certainly probably more economically focused studies on this that focus then on one singular aspect or several different aspects. But I think those didn't come up in my studies, because these normally don't consider the forest ecosystem anymore. So they are more focused on the wood that's already taken out of the forest. So I'm not sure if I can respond very well to your questions, but there definitely are some measures, and I can perhaps link you to some studies that I did found on this more kind of forest industry approach. There were not that many, but the ones I found I can link to you. But my focus was more on, let's say, the forest end or the forest ecosystem end. So that was interesting to be exposed to that side of forest kind of value chain.
Yes, thank you so much.
Yes, Ranju, please. And then I also have a question.
Hey, this is Ranju here. Can you hear me clearly?
Yes.
That's good. So let me quickly introduce myself. I'm working in SLU Umeå as a postdoc researcher. I started very recently, it's just a couple of months. So I'm working here on future forest program of the universities, mostly located, doing research project on Swedish forest. But also I'm involved to some extent in ONEforest program. So still at the beginning stage, but it's really interesting to see the presentation. It's a lot of things to learn as well, and also to see the multiple perspectives. So one thing it just came up to my mind just once you talked about resilience, which is really a spicy concept to me always. It's also a kind of buzzy concept buzz. It always raises buzz. So as you recently reviewed, and also you got a really fresh understanding of resilience, do you think it's just like a guiding umbrella concept? This is one thing. And at the same, and the other thing is how difficult you feel that to measure resilience from theoretical or scientific perspective, and then come down to the management level. You understand what I'm saying? So, yeah. So probably you can share a little bit. I mean, just kind of perception to see, because to me, resilience it's really interesting. I'm interested. I have some of my understanding on this in my academic courses, but always it's just like when you start talking, discussing, you will get this really nice definition and also penarchy, adaptive cycle. But when you come to the ground and to measure and then develop some indicators, which really tells that this is the cutoff point of a particular indicator or a particular area of resilience and the other. So how do you feel that? Thanks.
Yeah, I completely feel you because when I started this this review, I was very with the false perception that there must be some kind of common understanding on this topic, but of course there simply isn't. And I think resilience can be used and is probably very often used as you said, as a buzzword. It's a bit like sustainability in sense that it's, everybody throws it around. We are resilient. We aim to be resilient. We aim to be sustainable. But at the same time, when you ask, okay, so how do you do this? How are you increasing resilience? And all of a sudden the plans are very vague or there is no plans at all. And kind of funny anecdote on that one of the main reasons for me to not include a study in my review was that they used resilience, but they had no definition of it. So then I was also like, what are they actually talking about then exactly? So I felt like I couldn't then involve them in. So it can be used as a buzzword, and certainly some do that. But I think there is a bit similar as with sustainability, that there is real value to it if it's correctly used and if it's really kind of also understood. What does it mean and what are the potential and clarities to it? But I also think that that's why perhaps this concept of engineering resilience as the time of recovery is so popular on research, because it's so intuitive to understand, and it's, you can measure it, you can measure that actually. But with the other definitions like ecological and socio-ecological resilience, they become much more tricky, because there is usually there is not clear defined indicators or commonly accepted ones. Many studies do have their own, like a lot of remote sensing, like this NDVI is used as one indicator, or vegetation cover, for example, is used as an indicator. But I think what is tricky with resilience, it usually requires time as well. So it's more not so much that you measure at one point, but also like how the temporal dynamics change. And then how to translate that into, okay, this has a resilience value of 3 or of, I don't know, 5.8. Honestly, I have no idea. Like, I think that's still something we need to explore, and also depends on what is the system we are studying. If one thing I learned during these 4 years, it's that it's all context dependent. So, you cannot say that this is the way to measure resilience for everything that there is. But usually it always depends on the context, on the also the kind of who are we talking about, who are the stakeholders involved in this, what is the most resilient for them. So it's also about the people involved in the study, I think. So yeah, it's a really interesting, fuzzy concept that it's kind of difficult to pin down, but some people do try, and I think there's quite interesting advancements in there, and probably also coming also from the Resonate project and the ONEforest project too.
I think you wrapped up very nicely. That's good. Best luck in your PhD.
Thanks.
Yeah, thank you very much. Also from our side now, I think I will not ask the question, but we might, it might come up again. My question was related to the kind of practical application of the concept, because you also mentioned the fact that there are that practitioners are actually overwhelmed with the information, but they don't know how to use it in practice. So I think that's something we will definitely pick up also in other presentations, because I know we have also researchers in this network who work on the value chain resilience, for instance, which is very much related to the practitioners, and also then those who process the wood, etc. So that's something we can definitely pick up again in the future. I think what we learned today is that you can make very nice presentations with lots of visualization and less text on the slides. That's something that I think should be inspiring also for presentations in the future. And we learned that the research we do is well, we might not change the world with one PhD project, but we contribute an important part, or you contribute an important part. I'm just talking about it, that we will also in this upcoming years and in your project, we will learn a lot about what can be changed or must be changed by policymakers, practitioners, etc. So I think this is also something we will follow up upon in our discussions. So thank you very much from I think Raquel's and my side. I think this was a really nice first Exploring Forest Resilience webinar. We will have the next one on the 16th of September. We are looking for volunteers to give presentations from both projects again. So I hope you're not scared now, but rather encouraged to also share your knowledge and your research, and just approach us, either Raquel or myself, in case you're interested. And not sure, Raquel, do you want to have the final word?
Well, I would like to see you again in September. So please try to do your best to participate, and also invite your peers, your colleagues to join our session. So it was a pleasure, and I hope that we could keep having this kind of talks, because it's quite interesting, and for you guys it's quite challenging and also inspiring. So. Okay.
Thank you very much. Have a nice summer break, hopefully. Well, we've learned that researchers never have breaks, but I hope that's not true.
Thank you very much for your work.
Bye-bye. Thanks.
Bye.
Thank you.
See ya.
Bye-bye.